Hey guys, today we'll be looking at LeetCode problem 217 contains duplicate. So in this question, we are given an array nums which returns true if any value appears at least twice in the array and returns false if every element is distinct. So basically, we need to check if the array contains duplicates or not. In the first example, since num contains 1 twice, hence we return true. Similarly here, 1 is repeated, 2 is repeated, 3 is repeated, and even 4 is repeated. Hence our output is true. In this example, all the elements of nums are distinct. Hence we return false. So basically, in the array, we need to check that any of the numbers present should be there at least twice. One method of doing this is the brute force. This is the most intuitive way that we make pairs of all the values present in nums and check if any of these pairs have both values same. So we start by creating an outer loop and iterate over all elements of nums. Start with 0 and run till I nums.length. One thing to remember, array's length is checked by dot length and not dot length with a parenthesis and neither size with a parenthesis. These are wrong. So we need to iterate over all the elements, and then for each element we need to check in the rest of the array whether it contains a duplicate or not. So our outer loop starts from 0, but our inner loop will start from I plus 1 and runs till the end of the array. For example, if we have an array which contains these elements, our I starts from 0, j starts from I plus 1, we check if the values match, if not, we increment the j, again we check if the values match, if not, we increment the j, and yes, since it matches, we return back true. Similarly, for another example, if we have the values such as 1, 2, 3, 4, and then 2, our I would start from 0, j would start from I plus 1, we'd check the values are not same, hence j moves to the next one, the values are again not same, the j moves to the next, yet not same, j moves to the next. Since it reaches the end of the array, we now iterate I. I now points to the index number 1, j points to I plus 1, the values are not same, j moves to the next one, the values are again not same, j moves to the next one, the values match, hence we return true since we found a duplicate. For the case where all are unique, we would have start I with index 0, j with index 1, it doesn't match, we update our j, it doesn't match, we move I to the next one. J starts from here, it doesn't match, since we have reached the end of array, I increments again, so I is now index number 2. Since j would be I plus 1 and j also needs to be less than nums.length, I in this case is 2, so j would be 3, which is not less than nums.length. Hence we wouldn't be entering this loop and our answer would return false. The time complexity of this solution is O(n) square. Since we are running a double loop, our outer loop runs for all n elements and our inner loop too runs for all n elements each time. So hence n into n, we get a time complexity of n square. The space complexity is O of 1. as there's no extra element being created. A second way of doing this question is via sorting. So basically, if we sort all the elements of an array, the duplicates would be next to each other. Following this logic, we sort the array and then iterate over all the elements, checking them with the previous one. We start with the default sort method and then run a for loop over our array. We start with I and run it up till length. Since we are checking the element with the previous one, our I starts from 1 to avoid any sort of index out of bound error. Because if we have I 0, the nums I would be 0 and nums I minus 1 would be minus 1. This would give us an error. Hence we start it within 1. In those cases where we are comparing I with I plus 1, our I would start with 0, but then it would run till nums.length minus 1 to avoid the overflow at the last index. If any of the value matches with the previous, we return true, else we return a false. The time complexity of this solution is n log n. In Java, sorting is done by divide and sort method. So dividing the elements gets us the log n, and since all the elements are iterated each time, we get the n log n. And for the for loop, we run it once, hence n. So n log n plus n, as this is the bigger value, we get the time complexity of log n. Similarly, space complexity depends on the sorting algorithm we use. A third method is via hash sets. So hash set is basically a collection of data where each data is unique. Hash set does not store duplicate values. So here we create a hash set is present. We iterate over our array nums. We check for each of its element if it is present in the hash set or not. If yes, we return true. If not, we add it to the hash set and then move on to the next value. On reaching the end of array, if still we haven't found any present, we return back true. Now just a tweak in the same method is that the .add function of the hash set, this returns false if the element is already present in the hash set. So basically we add it and simultaneously check if it is already present. If yes, we return true. If not, we return false. We could also add all the elements in the hash set and at the end compare the length of hash set with the length of array. If both the lengths are equal, means there are no duplicates and hence we return false. If the length of hash set is less than length of array, we know there are duplicates and hence we return back true. And in no case can the length of hash set be greater than array. So the time complexity in this case is O of n as we iterate over the array once. And the space complexity is also O of n as our hash set created can have at most n elements. Thank you so much for watching this video. I hope I could explain it in better terms. For any doubts or suggestions, do comment down. Thank you.